This is another demonstration of a messenger library from LabVIEW. And this demonstration, I want to show a little more about how you would actually do a real project where two actors are talking to each other. And I've done a little initial work here. I have my project, and I've created a simulated hardware library, sort of a driver. And what this has is take reading, which take reading is just taking a simulated sine wave with a little bit of delay time to show the instrument delay of talking to an instrument. And self-test, which is an example where you ask the instrument to do something. So here I have an example self-test that takes a second, and it either passes or fails. I'll run that, passed, make it fail, failed. And then I made two actors. One's going to be my top level. That's going to be the main top level of the project. And the other one's going to be the instrument. Both these are created under the tools messenger library create actor from template. And they're of the DEV template. The instrument actor, which is going to call the driver. All I've done so far is I've created two actions, follow-on actions, self-test and take reading, which just call the sub-VIs. I've added the data, the frequency and amplitude to the internal data of the actor. And I've made a couple of buttons, self-test and read, that just call these actions. So at the moment, I can run this actor right away, read some data, perform the self-test. And thus I can debug my basic actor functions by itself, just by running it, run it, stop it, debug, before I actually call it from another actor. So also I haven't really done much. I've just basically added those two buttons. Now the top level, again, all I've done, other than change the icons and things, is I've added a copy of the instrument actor to my internal data. This is the class. Remember, if I show this, show class library, the class wraps the VI, that's the actor itself. The actor is actually just the VI that's talking. The class is sort of it's just a wrapper that other things use to refer to the actor. So I'm referring to the actor by this class object. And then I've added an action, start instrument 1, where I take the object and I actually launch it and tell it to show its front panel. And then I think in my initialized case, I call start instrument my action. So I should automatically start and run this actor and show its front panel. So when I go, there we go, I start it. I can use it, And when I stop the top level, the actor stops. Note that again, that's automatic. I haven't written any shutdown code. That's just any actor that is launched is sort of owned by the thing that launched it. And if the thing that launched it goes idle, stops, it will automatically shut itself down. Okay, so let's talk to this actor. Say we want to run the self-test from the main thing. So we need a button on the main. Let's actually hang on. Let's steal a button from here. So we're on self-test. So we need, of course, to make an event. So let's just create an event. Case self-test. Okay, and then we want to actually query our instrument. So first thing we're going to do is we're going to just do a synchronous query. That means we're going to ask the instrument to do the self-test, and we want to get the result. So there's instrument. We want to do, if you look down in this menu, it's called query and read. That's a synchronous, ask the instrument and wait for a reply. We want to send a message. We haven't defined a message yet. We'll do it in a sec. So we'll go, just make it obvious. Perform self-test. Perform self-test. Note the messages in this library are just strings. So we want to perform self-test, and then we want to get the result. So this queries and reads and it gets the contents as a variant. So our self-test is a string. So let's cast it to a string. One annoyance with variants is all this casting stuff. Need a string. Create indicator. Self-test. Okay, so there's where our self-test result is going to go if we push this button. Now we've got to make our actor actually provide this. So let's go back to the other actor. We could copy the message name. Need more real estate. So we go to our message received, and now we have a list of messages that we receive. So under other messages, I'm going to go add case and call it perform self-test. Now perform self-test is just going to call self-test. Oops. Now, but we need the information to get back to other actor. We got to reply to the message. Now, if you look at the bottom of this template, at the bottom, there is the message that comes in, passes through all these shift registers, and is available in every action case. Another thing that passes through is the reply. The reply, which by default is nothing, also passes through. And if you look at these actions, as these actions are executed, the final action that's executed, which is the empty case, is first error handling. And then down here at the bottom is the reply. So we reply to the initial message. Initial message comes in, we read it, but it comes all the way through, and then we reply to it. So as long if the message has an address attached to it, and the query makes an address and attaches it to and waits for it, we can send a reply back to that query in the main actor. So to do that, we've got to actually build a message. Oops. Sorry, let's get our template. Need more real estate. So we can write a message. Oops. Write a message. This. And then we're going to actually reply to it. Like that. So that will do the reply. We also want to give it a name. So we'll go status. Right, let's see. Oops. Broken. Why are we broken? Oh yeah, because we haven't connected the error. Right then, to the top level, see if that works. So we run, we open this, we hit self-test, and there we go. So the self-test was received, it performed the self-test, and the reply came back, self-test. So that's a query. That's let me show the help on that. So it sends a message and waits with a timeout. The timeout by default is 5 seconds. So if it's more than 5 seconds, it'll throw an error instead. And you can change that timeout as you want. So that's a query, but often we actually don't like that because, like, remember, self-test takes a second, and self-test could take 20 seconds or something, and we don't want our top level to be stuck waiting for 20 seconds because it has other things to do. It's doing other kind of user interface work, and so we really want to get this reply sent to us asynchronously. So let's do that instead. So asynchronously is, first of all, I've got to normally I have more screen real estate when I'm doing this. So now we're just going to send it rather than query. Let's get rid of this. Let's put this elsewhere for a second. So we're just going to send the message, not wait for a reply. We want the data to come back. And how do we get the data back? Well, on these send methods and on any kind of message writing method, there's a reply to place. That's where do you want the reply to go to? If you look up here in the top, after we start up, we get 3 objects. One is this actor's messenger. That's the communication method to get a message to me. There's a registration for a user event. That's where the messages actually go. So that's where we get to the message case. And an observer registry, which we'll talk about in a bit. So we can use this actor's messenger as our address to get the message sent back to us. So we will get the message sent back to us. So remember, the message was labeled status. So we go in here, find a message, create a case after. The status, I think. Status? Yeah, status. That's the message. So now we want to read this message. We're going to read. There's extract. I should have called it read, but I called it extract. Fortunately, extract will extract directly to a string, so we don't need that variant anymore. Oops, self-test. Get rid of that. Connect up these things. I mean, this is kind of, I'm connecting up the message even though there's really no reason to reply to it. I know that might be confusing. And I connect the error. Let's see if that works. There's a high chance that I spelled something wrong. Start it. Self-test. No, come on. Oh, there we go. Okay, so self-test failed. Self-test failed. There, the actual message was sent from us. Let's see if we can. So the message was actually sent to the other thing, but the reply was directed back to us asynchronously and came back as a message. Okay, so now if we look at our messages, one problem here is that we received a status message. But if we have a real application and we have like 5 or 6 instruments and they all have status messages, how are we going to tell them apart? Also, when we're reading our code, status is very vague. I mean, status in this instrument actor, status is obvious. This instrument actor only deals with one piece of hardware, so obviously it's the status of that hardware. But here, the top level deals with many pieces of hardware and many things. Status can mean anything, so this is actually pretty poor. We want a different message to come. But again, in this actor, well, top level wants to deal with instrument 1, because that's what it understands. But the instrument doesn't know it's number 1 of anything. It could be 3, 4, or anything. So it doesn't want to deal with that. We want a way for the top level to decide what message it receives in reply. So let's go back to self-test. The way we do that, oh, better stop it. The way we do that is something called, possibly badly named, an observer and a translation VI. What this does is it takes an address and it converts it to something called an observer, which is really sort of a specially configured address that will do something to the messages before it sends them. So there's a number of options. One, it can substitute one message for another. Relabel messages, which is what we're going to use, and a number of other things. So we're going to relabel our messages. And this is what you want to relabel them with. And we're going to relabel something that means something to us. So we're going to say instrument 1 status. That means a lot more to us. Instrument 1 status can be distinguished from other things. And then we change our message here, rather than status, it's instrument 1 status. And actually, let's just make this instrument 1 status 2. So it's obvious. Ooh, status. Right, now when we start it, let's start this as nothing, so I can actually see it. Now when we run self-test, we get the same thing. We came through, but now it comes back as an actual meaningful message to us. Instrument 1 reports its status. I use this little arrow thing to sort of indicate from where this came from. Where did this come from? You can use any other kind of mnemonic that means something to you. Okay, so that is, let's review that. Oops, don't do that. Don't accidentally put that on. How do we do that? Oh, don't do that, man. Sorry about this. I hate breakpoints. Remove it. Yeah. No bloody breakpoints. Thank you. Get it off, hopefully. I really hate breakpoints. Okay, so that's how we do status. Now we want to do our readings. Now readings are different. We don't want to ask for a reading. We want readings to be sent to us whenever they're available. And that requires, first thing, that our little instrument actor can actually take readings constantly. Currently it doesn't. Currently when we run this, It just reads whenever you push the button, which is not what we want. So, turn off. So how are we going to make this stuff do something continuously? There's more than one way to do this. A more way you're probably familiar with is using the timeout, but I'm not going to use the timeout. I'm going to use another possible method. I think I'll use a metronome. So a metronome is one of these useful actors that come with a framework. So we're going to start a metronome. Metronome is something that will send us a message periodically. So we're going to say every 500 milliseconds, it's going to send us a message. And what it sends is something called a metronome tick message. So if we give ourselves the address to the metronome will send metronome tick messages to us. So let's start. Let's create a message, add case after, metronome tick. And on metronome tick, we want to take a reading. So, oops. That. So every time we get a metronome tick message, we'll take a reading. Why is that broken? Hang on. Oh, again. Always have to do your error stuff, even though when you're trying to ignore it. Now I run this. And you see it start taking readings automatically. That's because it's receiving its metronome tick messages twice a second. Now, so we're taking readings twice a second, but how do we get it back to our top level actor? Here we want to use something which is called register notify. Under observer register, we have notify. We'll do notify event. This observer register, by the way, is really, it's a DVR with like some kind of lookup table. It handles who wants what information and sends it to them when they need it. So we want to send, we want to send our readings to whoever registers for them. No, we're not sending the message to the top level. This actor here, instrument, has no idea who top level is. It just knows it has information that it's going to make available to anyone above it in the hierarchy. So it's going to send reading messages containing the latest reading to whoever has asked for it. Now let's go to the top level. How do we ask for it? Well, when we launch it, we've got to send it a registration message. And we've got to register for by label. We've got to say what message are we interested in. Oops. So we're interested in reading messages. Oops. Not send. Okay, send register. We're interested in reading messages, and we want them sent to us. But again, we stop here because again, we're going to get reading messages. If we have reading messages in our message list, and we got multiple instruments that take readings, that's not going to be very clear. So again, what we want to do is use our message translation and actually relabel what the message is. So it's something that's more clear to us in the context of the top level. So again, relabel messages. We'll relabel it not reading, but instrument 1 reading. We can instrument 1 reading, or we could actually put in what it is. Maybe our instrument is a temperature or something. We could put instrument 1 reports temperature or something. So instrument 1 reading, and then of course we need to handle this message when it comes in. So let's just duplicate, add case after. Instrument 1 reading, and let's see. So I'm going to use extract a variant. This makes it slightly faster to code. To variant, and the reading is a double. And create indicator. Create indicator. Instrument 1. See if that works. So let's go over again. This should work. When we launch it, we send it a registration message for reading. We have it relabeled to instrument 1 reading, which we're prepared to handle. And in the other actor, we notify readings. So let's see if that works. Yeah. And you can see the readings are actually coming in as they are taken here. Let's see. Let's use a probe. See if we can see the messages coming in. Custom probe. Remember, the custom probe is a message cyclic table. So, that's the actor class with the metronome tick messages. I wanted the top level. Let's see. Top level probe. It's receiving instrument 1 reading. And again, because we relabeled, the big advantage of relabeling is that you can keep track of all these messages because they actually mean something. Reading is too vague and status is too vague, but instrument 1 reports reading, instrument 1 status, these mean something. Okay, so let's go over again. So yeah, that's the 2 different types of primary communication: request reply, which can be synchronous or asynchronous, and register notify, which is always asynchronous generally. Let's see, what time is it? And I think I'll stop here for the moment and do another video later on. Thank you very much. Goodbye.